The Sudokwon Landfill Corporation, or SLC, developed an energy town to meet increasing energy demands in the country and lower the use of fossil fuels by creating energy from waste. Transforming waste into energy is consistent with South Korea's resource circulation and green growth development strategies. The SLC has developed state-of-the-art facilities for converting different types of waste into energy. The ability of SLC to convert waste to energy in a cost-efficient way is due to their existing system of waste separation. See Module 2 to learn about how waste is separated. Currently, SLC is converting 25% of incoming waste into resources, and it aims to raise the resource conversion rate to 77% by 2023. The following facilities are main waste-to-energy facilities in SLC's Energy Town: a 2.4 megawatt biogas power plant, a sludge recycling facility, a food waste effluent to biogas facility, and a combustible waste-to-energy facility. In order to generate biogas, which is the raw material for the 2.4 megawatt biogas facility, the food wastewater generated from the treatment of food waste is carried in through the entrance of food wastewater. An average of 40 trucks a day carry food wastewater from 6 a.m. to 3 p.m. every weekday except holidays. The imported food wastewater is stored in the biogas storage tank and then transferred to the 4 biogas digesters. The wastewater inputted to the 10-meter-high biogas digester is properly mixed, and microorganisms are properly decomposed through an anaerobic digestion process, thereby generating methane gas. In order to create an environment in which microorganisms can live, an appropriate temperature must be maintained, and for this purpose, a boiler must be operated. In this process, SLC is operating a digester boiler by recycling the biogas produced by itself, rather than using fossil fuels. Hydrogen sulfide and biogas dissolved in water produces sulfuric acid, so it must be used after a strict pretreatment process. Therefore, biogas goes through 6 desulfurization facilities for purification of hydrogen sulfide as the first desulfurization process. The biogas storage facility is a place to store the gas from which hydrogen sulfide and moisture have been removed after passing through 6 desulfurization towers for the digested gas generated in the leachate treatment plant. A 65% methane concentration, which is good methane gas for power generation, is stored, and the amount of biogas generated is about 40,000 to 65,000 cubic meters per day. Methane gas stored in this biogas storage facility is used for fuel for 2.4 megawatt and 1.9 megawatt power generation facilities, greenhouse heating, and boiler fuel for the heating system in SLC. The methane gas purified once is purified once more and lowered to less than 1 parts per million. In addition, SLC has increased the efficiency of desulfurization by using a hybrid desulfurization agent since 2019. Therefore, the estimated generation of 39.2 tons of waste desulfurization agent at the time of design was reduced by 50%, resulting in 19.6 tons. These secondary desulfurization facilities are operated with a 900 normal cubic meter per hour capacity. The moisture contained in the biogas is removed through an 11 kilowatt dehumidifier to prevent the hydrogen sulfide from being dissolved in the water. Since biogas contains a lot of moisture and dust, it undergoes a process of removing moisture and dust to properly treat it. This biogas pretreatment process prevents the formation of sulfuric acid by combining moisture and hydrogen sulfide, and this is to prevent the gas engine of the generator from failing. The biogas that has gone through the pretreatment process is blown to the gas filter through the biogas blower. In this manner, methane gas, from which hydrogen sulfide has been removed by 2 stages of pretreatment, and dust and moisture are removed through the dehumidifier and dust remover, is sent to 8 generators through a pressure blower and a gas filter that removes dust at the final stage. Before being put into the generator, the gas flow is checked and pipes are gathered into the headers. Fuel is supplied to the 8 generators through 8 pipes. The gas engine generator, the core facility of 2.4 megawatts, is a small and medium-sized generator that uses strictly purified high-quality digestive gas as a power source. It transfers mechanical energy to the cylinder and crankshaft by utilizing the explosiveness of 55 to 65% of the methane gas and converts this energy into the electric energy we use by the electromagnetic induction inside the generator. By operating 8 300 kilowatt generators, a total of 2.4 megawatt generators, it produces 9 million to 10 million kilowatts of electricity annually. This is the amount of electricity that 2,500 households can use for 1 year. In this way, SLC efficiently collects and treats biogas generated from leachate and food wastewater through a 2.4 megawatt power generating facility, minimizing odors and generating electricity to generate profits. SLC is participating in the national alternative energy business and contributing to environmental improvement by reducing greenhouse gases and improving air quality. It is a nitrate oxide reduction device. This is a device that utilizes SCR technology that has secured patent rights by conducting joint research between SLC and a domestic company. SLC is producing electricity by reducing nitrogen oxides through SCR technology to comply with the Total Air Pollution Load Management System and minimize air pollution. Additionally, in order to operate the 2.4 megawatt biogas power plant normally, SLC is monitoring and controlling it through the HMI system. This allows SLC to check data such as coolant temperature, generator status, hydrogen sulfide concentration, and flow rate in real time. The HMI system is designed to be able to check remotely even if it is connected to a smartphone and away from the facility. The electricity produced through the generator is connected to the KEPCO substation through the transmission line buried underground. It goes through the process of boosting the 380 volts of the generator to the 22.9 kilovolts to supply KEPCO. It is constantly monitored to check the safety of 2.4 megawatt facilities through the power distribution facilities that can control safety devices such as generator controllers, transformers, instrument panels, and circuit breakers. Sewage waste used to be thrown into the sea, but this became prohibited in 2008 with the signing of the Convention on the Prevention of Marine Pollution by Dumping of Waste and Other Matter. This is known as the London Convention. Korea found a way to deal with sewage by converting this to energy and other useful resources like cover soil for the landfill. SLC installed a 4-story sludge recycling facility with a total floor area of 11,800 square meters. This is an eco-friendly facility for recycling resources. The facility safely treats and dries 1,000 tons of sewage sludge per day and converts it into fuel. Sludge collected by the sludge transport vehicle is stored in the sludge storage tank after entering the loading area. Since sewage contains a lot of moisture, it is crushed to make the particles smaller and dried with high-temperature hot air. The sludge is then crushed by a disintegrator and dried in a kiln with rotating dryer at a temperature of 800 degrees Celsius. Drying reduces the moisture content from the sludge from 80% to 10% or less. Crushed sludge is dried more effectively since its total surface area in contact with hot air is maximized. The sealed rotary kiln structure blocks the spread of odor. Additionally, the odor generated by the drying of the sludge in the sludge-to-energy facility is safely discharged through a hot fan and air preheater, through a washing tower, a biofilter, a wet scrubber, and a white smoke reduction heat exchanger. Agglomeration and fixation are prevented through particle atomization, and as a result, safety devices are installed to prevent fire and dust explosion that can be caused in the process. Dried sludge passes through the filter dust collector and the dried sludge cooler, then stored in the dried sludge storage tank. The sludge is molded and discharged later. Wastewater and condensate are treated in a wastewater collection tank. All these processes are automatically operated through a computer control system. Important facilities are constantly observed and controlled from the central control room through a monitor to maximize the operating conditions. In order to prevent fire and explosion occurring from abnormal operation, a fire water nozzle is installed at the outer part of the inert compartment. The water nozzle is designed to operate at a set temperature of the outlet. In the sludge storage tank, a thermometer and a carbon monoxide sensor is installed to automatically inject and spray nitrogen gas in an emergency. Food waste effluent refers to the wastewater that is extracted from the food waste. Food waste used to be dumped into the sea, but this practice is now banned by the Korean government. The food waste effluent to biogas facility at SLC is an eco-friendly facility that treats 500 tons of food waste effluent per day and 182,500 tons per year. The facility has a total floor area of 3,573 square meters and a building area of 4,724 square meters. After food waste is collected from homes and businesses, it is taken to district facilities where the food waste effluent is extracted and then transported to SLC for processing to energy. The transport vehicle with the effluent enters the loading dock and inserts food waste effluent into a receiving inlet. Impurities greater than 8 millimeters are removed, and food waste effluent is transported through screen drums and placed in storage tanks that have 4 agitators and defoamers to efficiently mix the effluent and suppress foaming. It is then transferred to an acidogenic digester, where food waste effluent as an organic matter is processed through both an anaerobic methane digester and a stabilization tank. The facility collects biogas that has been generated during this process and stores it in the upper part of the stabilization tank. Biogas stored in the upper part of the stabilization tank undergoes a refining process in biodesulfurizer and ventilation devices, as well as biogas dehumidifiers, and supplied to the regenerated burner as a high-quality safe biogas. About 23,000 cubic meters of biogas is produced per day that has a methane content of 60% or more, hydrogen sulfate concentration of 500 parts per million or less, and moisture of 5% or less. Food waste effluent in the stabilization tank is then sent to a high-efficiency aerobic reactor for reducing nitrogen content to meet the standards for linked treatments of the plant. The sludge generated during the process is discharged and buried with the centrifugal dehydrator, and the decomposing filtrates are transferred to the Sudokwon landfill site. Odors generated during this process are classified into high concentration and low concentration odors and collected through odor pipes. High concentration odors are burned using a regenerative combustion facility, while low concentration odors are treated in wet chemical cleaning processes and discharged. All processes are automatically operated with a computer control system. Facilities are constantly observed and controlled from the central control room. 200 tons of daily waste, categorized as non-recyclable waste, is brought into the Sudokwon landfill and stored in the loading area. The waste is broken down into smaller sizes using a crusher. Crushed household waste is transferred to the mechanical pretreatment area of the facility. There, waste is sorted in sizes of 100 millimeters and 300 millimeters through a trommel screen. Waste is classified into light and heavy waste according to its weight with a wind separation machine. Waste is sorted into combustibles and non-combustibles by an optical sorter. Iron, among non-combustibles, is sorted by a magnetic sorting machine, while non-ferrous metals are sorted by a non-ferrous metal sorter. Sorted materials are then recycled as valuable resources. The selected combustibles are crushed into pieces smaller than 50 millimeters with a crusher and moved to the drying facility. Here, crushed combustibles go through the drying process in a rotary drum dryer to achieve a moisture content of 10% or less. Waste that passed through the drying facility is reproduced as solid fuel products. A ring die sorting machine shapes solid fuel that are less than 20 millimeters diameter by 50 millimeters length and size. These are then transferred to the cooler storage chamber and taken out through carrying out machine. Fine dust and odors from the drying facility are removed by utilizing deodorizing passage, cyclone dust collector separator, and bag filter. Heat from the deodorizing passage is recovered as thermal energy through a heat exchanger. Odors generated from the loading area and pre-treatment facilities are prevented from spreading to areas outside the facility by passing the air through a liquid cleaning chemical scrubber. 1 ton of solid fuel produced at this facility has calories equivalent to around 500 liters of oil. This solid fuel is utilized as thermal energy or electric energy through a dedicated boiler. We can secure new and renewable energy by processing and utilizing waste as an alternative fuel source while reducing the burden on landfill sites.